Welcome back everyone to our statistics class notes. We're now at the top of page 97. We're in the middle of our first simulation we were studying a population of 8 people whom were going to participate in a 5K running race. And we happen to know that 2 of them are walkers, they're going to walk it, and 6 of them are runners. So in taking samples of size 4, I was showing you on the last page how 57% of the time, probability of 0.57, our sample would also have one walker out of my 4, which is a p hat of 25%. Now remember, our population proportion is p, which is 25%. So 57% of the time we'd get a sample that represented that exact population proportion of 25%. But remember, with the sample of size 4, we can only get 0 walkers, 1 walker, or 2 walkers to get 0%, 25%, or 50%. Because there's only 2 walkers in the population of size 8, so a sample of size 4 cannot have 100% walkers, right? You can't get even 75%. You can't get 3% walkers. You can't get 3 walkers out of 4. You can't get 4 walkers out of 4 because there's only 2 in the population. Now, what is the mean of this sampling distribution? Notice that the mean, the predominant one that you would get, is 25%, which is actually the mean, or which is actually the proportion of the entire population. And we will see that as we build these, the mean for a sampling distribution, which is what this is the samples, how the samples would be distributed. The mean of it will always be the population proportion, which is very interesting and actually part of the central limit theorem. So notes about this simulation. Our estimator p hat is not always the same as our parameter p, right? It's not always the same as our parameter p, which is 25%. Our p hat can either be 0, 25, or 50% in this sample, with this sample size and our population size. The mean of the sampling distribution is 25%, which is the same as the value of p, the population proportion. This indicates that the estimator p hat is unbiased. That is what I mean by accuracy when I said we're measuring our surveys by accuracy and precision. Even though p hat is not always equal to p, the estimate is never more than 25% away from p, right? Because we only get 0%, 25%, or 50%, so it doesn't get any more than 25% away from p. Now the standard error is another term that we're going to use. Okay, now when we talk about sampling distributions, when we talk about the standard deviation of the sampling distribution, the words that I will use are called standard error. But don't get confused by that. It's just the standard deviation of what is known as the sampling distribution. It measures how much an estimator typically varies from sample to sample. When the standard error is small, we say that the estimator is precise, and then we would have both accuracy and precision.